Hello. How you doing? Welcome, welcome. Edifaus, hello. How's everyone's week? Hopefully it was swell. Mine was alright. Yes, we're continuing with this. I did a little bit of stuff off stream. We'll see that here in a second. Epic! 66 months. Thank you for 66 months. Welcome. How you doing? Why are there lyrics in this song? I specifically ask for no lyrics. All right, how you doing? First reset of 2025. 2025! But hey, guys, doing? How was your week? Hopefully it was good. So I did a little bit of work here. You can actually see some of the. I'm pointing up there. Just there's some stuff there. That's a bit of what's it like profiling, kind of. I think am I running at? I think I'm running slower, so I can. Yeah, so I'm running at quarter speed, so it's easier to see that stuff. That only happens for a single frame, right? That blue there is the IRQ time. What I'm doing is I'm changing the color emphasis bits during the frame. So the main menu only has the IRQ stuff going on. The frame itself, though, sorry for the flashbang, number one, but I needed to change the background so I could actually see the color changes here. So again, we've got the IRQ up there, which is drawing the entire playfield, as well as the hold and the next, and even this little debug thing up there. With this was helping me figure out some collision stuff that I was actually able to track down and iron out over the past few days, chiseling away at it here and there. So yeah, the blue or purple, blue, whatever at the top is IRQ, and the green is the frame itself. So or the frame processing stuff, right? So I set that right at the start, and I unset that right before I wait for the IRQ to finish. Not just the NMI, but also the IRQ. And I've also bumped that up a little bit to the second line. It's going all right. It's going not too bad. Basically, to avoid needing to use the event viewer for timing issues. Yeah, so it's not exactly like timing issues I'm tracking down. It's more of an overall feel of like how inefficient some of the code is. Spoilers, some of it's pretty terrible. I actually need to get a debug board up so I can show it a little bit better. Let me actually do that real quick. Screens, debug. Okay, so we're gonna use this. We're gonna change that. 1, 2, 3, 4. Okay, and then for most of those. And then right there. Okay. Good evening, Cybers. How you doing? Something crazy happening? Uh-oh. Good kind of crazy or bad kind of crazy? What kind of crazy is it? No. Minimize. If I send them to the back versus minimize it, it like changes. What's it? The Alt Tab order of things. That's kind of annoying. Not gonna lie. All right, so set it up here. So a single line piece will clear 4 rows at once, right? I'm gonna go over here. That's the wrong file. Game debug piece number 5. That is the line piece. Make. I need to actually turn on the debug field as well. Make that again. I can come over here, reload that. All right, So we've got a debug field. I did actually fix this piece being able to go all the way over to the edge. So that's cool. On both sides even, right? But I'm going to set a breakpoint so we can actually see this happen. So debugger and... Do I have these set already? Go to location. Oh, okay, they're going to be all wrong. Okay. Oh, it's right here. Do hard drop. Okay, so I am putting a breakpoint on the event of me pressing up, essentially, which does the hard drop action, right? Breakpoint there. I'm going to put another breakpoint at the end of the frame processing so we can see how far it goes, right? Where is load block button released, button released, button released? Where is right here? Wait for IRQ. All right. Oh, okay. Well, we won't see it on that. We will see it in the event viewer, however. That right there is how much frame time this is using up. Hang on, let me turn off the list view. I gotta close and reopen that event viewer. There it is. That's a lot. That is a lot right there. Flight attacks for phones. Uh-oh. The terms of the attacks are complicated, but they aren't important to explain. They're released on iOS and Android app. They give you your device's number. Oh, okay. After showing large in size, 250 meg. Scan the Android version of the app. Open source service called Exodus. I think the charges the permissions asked for were 32. Camera mic. Oh goodness. Oh, that never ends well right there. What do you want to access? Yes. Huh? No. No. You're not accessing all the things. That's shady as hell. But yeah, so as you can see, the majority of the frame now is doing some calculation bullshit. So I do want a two-player thing, a two-player mode, working in this, right? That's what this mock-up is. This is not this is not programmed. This is just a mock-up to a layout of the screen, right? But I know what I'll have to do to get this working, right? I'll have to be able to write 400 bytes of data plus 4 pieces during the IRQ, plus all of, like, the processing that I'll need to do for that frame, right? Millions of installs, a couple... Well, I mean, it makes sense to get that many installs. This doesn't mean it's not shady, but, you know. That's not... I mean, not still doesn't mean it's doing things that people would disapprove of. How about that? But yeah, so if both players hard drop on the exact same frame, that means that processing the board goes over into the next frame, which is no, we can't do that. So I need to make some stuff a little bit better. I need to make some changes here. And yes, that's a lot of both processing and writes. Right, and I came to the realization on my drive home from work today. Currently, I am updating the board and the hold piece and the bag and all that shit every single frame. I came to the realization, if I am updating the field because it needs to be updated, the next frame cannot also update the field. So the fastest you will be able to press a button, because that is the fastest I am checking the button, is once per frame. So you press the button for hard drop, it executes the hard drop. The next frame, that player can't execute the hard drop again because the button release hasn't been registered yet. right? So there's at least one frame where I know, like, the board can't be updated. Which means I shouldn't be updating the board every frame. I should only be updating that when I need to. Right? So in theory, that'll help a little bit. Another good chunk of this is let me get a this guy here, a profiler. Where is that profiler? I'm gonna reload this real quick. Reload. Start. We're gonna disable that one for now. Do that. Bop. Hard drop, thank you. Turn this back on. Over here. Reset profiler data. Okay. So, this is the profiler stuff for everything that just happened, right? Everything in that green area. Right here that just happened. I've got one call to hard drop, do hard drop, fair, which calls basically most of this other stuff. Update block is very expensive. Oh my god. 28% of the execution time was that. Calculating the ghost is surprisingly expensive. I didn't think it was going to be that bad. Clear row is kind of expensive. I could probably trim that up a bit. Worst case, you still do need to update the entire board for both players. In one frame, though, like you said, simultaneous hard drops clearing at the bottom. Right. So if I have to do, like, what's it? If I'm doing simultaneous hard drops, I'm not updating both the boards on the screen that frame. That'll be the next frame, right? And then when I am updating both of those, I'm also, because I'm redrawing the screen, I'm not also updating the playfield, right? So I figured if I can get the worst case processing down enough, I should be in a lot better position, right? In theory. But yeah, so for the clear row stuff, I probably want to revisit some of that, especially how I'm calculating the clear rows. I mean, the processing for the hard drop happens in one frame, and then the rendering happens the next. Yes, exactly. Yes. Yeah, it's figuring out what needs to be cleared. It's figuring out the new board layout with all the rows gone, that kind of stuff. Now, with removing the rows, with that, and not updating the board every frame, I could, in theory, divide up, like, the clear row stuff, right, across multiple frames and make an animation out of it somehow, right? Like, if I take those 4 rows and, like, replace all of their blocks, all the tiles, with a special tile that does an animation or whatever, or like a white tile or something, right? I think that's what the Nintendo Tetris does, is it replaces all of them with one tile and then gets rid of them. I can still update the board in the background and not update the board on the screen, because I haven't called for it to be updated yet, right? Which would, redraw the whole board. Checking for the row clear is a little expensive. I think I want to clean that up a bit. And the way I'm thinking of doing that is keeping a running count for how many blocks are in each row. That way, instead of checking 10 cells to see if that row is clear, I check one number, right? So every time a block is placed, for each row that the block occupies, just add that number of blocks to that row's count, right? And I do want to revisit how I'm doing the clear row stuff, because I looked at it again briefly the other day, and I didn't like how I was doing it. So we'll probably... I don't know if I'll get to that tonight, though. And the other thing that is really costly, kind of costly, I want to actually put some more color changes in the emphasis to break some of this stuff out. Like update block and calculate ghost. Actually, does one call the other? Calculate ghost. Yes, update block calls calculate ghost. Okay. So in here, let's take this. We're gonna emphasize red, I think that's what that is. And then here we're gonna go back to the other one. Stuff. I think so, yeah. Yeah. So I want to see that like split out a little bit. Registers 01. Okay, so that'll put it blue. And then after the... Okay, so here I want to make it green again. Okay. So, let's do that. Let's go over to here, reload that. Start. Yeah. Rotate that. Hard drop. Okay. So, the red is the calculate... Is the number conversion? No, that's the I'm sorry, that's the ghost calculation. Why is the ghost calculation so much more than over here? That was just the ghost calc, right? Calculate ghost. What color is that? Emphasis red. Really? That seems awfully expensive for that. But yeah, the actual update code is minuscule, right? That's next to nothing. So I'm not going to really worry about that. Oh God. Yeah. Calculate ghost. Yeah, the update block. I'm not going to really worry about that because that's mostly calculate ghost. That's mostly what that is. The vast majority of it. That's other stuff though, like that. That hard drop stuff. Like what am I actually doing in that? Hang on. Do hard drop. What's actually happening here? I'm setting the screen shake, and next block. No, it's the clear rows stuff. Okay. So that's all calculated in clear rows and the what's it? The updating of the board. All right. Well, first, let me make sure that my code is clean. Game. It's not quite clean. Okay, so this is just the changes I have for the profiling stuff. So I'm not too worried about that. Diff main, same thing. Okay. And these weren't really added in, were they? Scores. Oh, yeah. Okay, so that's that. Yeah, I'm ignoring that for now. Okay. What did I say? What was I gonna do? Oh, yeah, okay. So, IRQ, this draw board right here. Draw bag contents, loop row. Okay, draw playfield here. Load up. Flag playfield ready. Flag playfield ready. Branch equal, branch not equal, like that. RTS. Yoink, paste. Oh no, we're gonna load up 0. Store that there, clear it out. Okay. This load up. Ooh, actually, start clear rows. This guy here. Let's just put it at the end of this, because after the rows are cleared, it's right there. That's when it's gonna need the stuff updated, and this should handle the hard drop and the not hard drop. Load up 1. Store that into flag playfield ready. Yeah, it was fine. Make. All right. Let's see if I broke things. Close out of that for now. Let's close out of that for now. Over here, we're going to turn these off. Sandra Pony, how you doing? All right. I'm still going. Ooh. It never updates. That's cool. It's real cool. Why is the IRQ taking that long, though? Actually, no, that's not very long for the IRQ, is it? I mean, I guess I could... Well... Clear with empty, jump bottom. Check... Do clear row. This guy here actually clears a row. That I need to unroll that a little bit, I think. Start clear rows. Do I just want to... Maybe I'll just put it there. Not that this is what's actually wrong, but, you know. Yeah. Well, for the first... Actually, init. And... I do want to... Put that there. Okay. Start. Okay, drew that. But it's not drawing it. Why is it not updating that now? Hard drop. Let's step through this. And let's flag play field ready. Like that. Okay. Place block doesn't set it, which maybe it should. Actually, yeah, probably place block should. Yeah, place block needs to do that, because it's not just when I'm clearing it. God damn it. Place block, right there. RTS. Grab that, put it there. Because even if we're not clearing it, clearing it, we do need to update. Right, come on, thank you. Make. Okay. Reload that. There we go. Okay. That was better. Let's set this up again. Okay. Which one is this? Hard drop. And then this. Yeah. No. Debug event viewer. Okay. I mean, it's a little better because we didn't update the screen this time around, but yeah, so that clearing of the rows. Let's move some of the coloration stuff to that. Okay. What's the green area again? A lot of things. So start clear rows. That's going to be... What the hell is this? That's going to be red for start clear rows. And then the do clear row, JSR, this is going to be... What does this actually do? That just clears a single row. So this... that. Yoink that, paste it there, and paste it there. Because that's going to be red, or turning back to red. Let's do blue. Make. Thank you. All right. That will add a little bit to it, but that's fine. All right, so let's get this set up again. I need to reload, actually, so... Okay. That one. So that's the check there. All right, so each of those blocks of the blue there, that's clearing the row. Okay. Yeah, so I think I want to try to clear make that a little bit more efficient. And that do clear row, yeah. And then I don't actually... Yeah, the next block is... We're going to make that green again. Because that's the exit there. Green's the second one. Yeah, green's the middle one, okay. Here. Whew. All right, next block is expensive. Next block is the one that's... Wow, okay. All right. How many... Well... What the hell is next block doing? Jamaica, how you doing? Takes a bit more than a scaling H, but you said it can be unrolled for... Yeah, it can be unrolled a little bit. Yeah. What are these? Register. Oh, that's the register rights for that stuff. Yep. 50 months! Halfway to 100. Thank you, Joe Mega. How's your week?
50. Halfway to 100. That's gonna be a while.
Next block. As long as had iterations So even completely enrolling it isn't reasonable. Yeah, yeah. Should help at least a little bit. Oh, this might do the bag. Well, bag shuffle shouldn't be too bad. Shuffle bag. Worst case scenario, right? So I'm not too worried about that. Check some collision stuff again. After it loads the block. Load block. Doesn't do too much there. Yeah. Lazy is not assigned to a project yet, just getting paid money to wait. Nice. All right, let's start with what was that? The do clear row. Let's start here. Just for shits and giggles, we're gonna unroll this entirely. Repeat 10. Just 10 times. And repeat. All right, so basically, like right to the top of the hold, it's getting to. Remake that. See how much that saves us. Start. Oh, yeah. Turn off that one. Rotate. And then there. Okay. Event viewer. Saved a little bit. Saved a little bit. Actually, I saved a few lines, didn't it? I saved quite a few. Yeah. How's it going? It's going. It's going. How you doing? Okay, so let's have a look at next block. This guy here. I'm sorry. Load block? Well, let's switch the color stuff to next block now. 1001. So not from there. So next block is going to be red. Yeah. Do clear row. Well, hang on. Next block, RTS. There. That'll change it back to green. And then this clear row stuff, I want to get rid of those there. All right. I said reload, damn it. Thank you. I think it's that one. No, it's that way. Start. Okay. Really? Shaders? No. No. All that for net. Well, so that's just this right here. This is the next block. And checking with the collision even. Checking the grid collision. To make sure that like you haven't what's it? Topped out, right? Which I suppose on a... Well, that's not necessarily true, I guess. I don't know. That might not be entirely necessary on the... I'm keeping that anyway. It's fine. This part of it, though. So whatever's after, do hard drop. So that goes to hard drop done. Calculate the score. calculate the score, and then update block. Update block does the what's it? The sprite stuff, I'm pretty sure. Does the ghost, and the sprite stuff. Yes. What was blue at the end of that? What was that blue bit? So this is turning it back to green. Takes a while, but I suppose on unreasonably much. I was going to check some. Yeah, I mean, so that's not too bad. I'm not too worried about that. Hard drop done. So that turns that off. The emphasis off. Okay, so why is it update block is turning it blue there? Okay, so that's updating the block right there. What happens if we turn that back there and then... So just for calculate ghost again, because I don't remember how bad that one was. Really? Calculating ghost is that bad? Yeah, that first step was one hell of a confusing name at first. Mao. Trying to follow your necessarily for a long time. But you always stream when I should be sleeping. Oh no, I'm sorry. I'm sorry. Glad you're here. Appreciate it. Yeah, that is a significant amount of time for the ghost. Not gonna lie. What is that actually doing? Oh, is this the one that's got... This is the one that has the... this crap in a loop! It's got the multiplication in a loop. God damn. Yeesh. And then this one checks every single row for each column individually from the current piece down. So the higher up it is, the more time it's going to take. I'll turn these off. And the more rows, columns it has. Oh my god. Because it exits early for the columns it doesn't have, right? If I move this down more, that should, it gets shorter and shorter the less distance it has. I'm not sure how I'd optimize that too well, though. So this does multiplication here. So bunch of setup crap, right? Figuring out some initial values or max values for things. And then starting at the top value. So starting at where we begin, essentially. Compared to 4. So if there's nothing in that column, it skips to the next. That's why the flat, when it's horizontal, it takes more time than when it's vertical, because it's calculated in 4 columns instead of just 1. Yeah. Is this a case of necessary or premature optimization? This is going to be necessary. The reason I'm doing this, Captain Pie, is so I can do this twice per frame. 2-player stuff, right? Yeah. Implement Python? No, I would not speed things up. That'd slow them down. Python's not fast on like modern hardware. Forget about 8-bit. Yeah, and then I have to loop through each of these. I suppose I could check all 4 columns at once, maybe? Python to run that? No. No. So like I said, currently it goes 1 column at a time, right? I'm pause this right here. Yeah. Yeah, so currently it goes 1 column at a time. So because it's flat, it checks this entire column, finds the bottom. Checks this entire column, finds the bottom. Checks this entire column, finds the bottom. And then again, one last time, checks this entire column, finds the bottom. Would it be it would probably be better to just check all 4 columns on that row at once. Right? Save, and then if I find something, I'll just save that as the lowest there. Since then he won't need to row step as often? Yeah. But then I will need logic in there to make sure that the lowest value that I'm overwriting well, I'm writing this every single time, aren't I? Yeah, we need to keep track of each column a little bit more thoroughly, yeah. Or carefully, yeah. Another one with freaking lyrics. Can you not with the lyrics? Are you checking if it has landed? Yeah, I'm checking if it. I'm checking for this right. I'm doing the math for that little piece right there, which is the ghost piece, right? Basically, I want it to go as far down as possible, without like overlapping the next block, right? Now it might be a little deceptive with deceptively easy with the line piece. So let me change that actually. Let me change that to the T block. So that's what ID 2, right? And I don't want the debug field. Okay, so reload that. Okay. So we're going to drop one. There. Okay. Can you store the highest current Y as a variable and check that? Well, so I initially thought of that. Overhangs break that. Right? So if I... Hang on, let me build up an overhang here. Bam. I need to make sure that under here, it doesn't go above this block here. I need to make sure it doesn't go up there. Right? Yeah. Which was a problem. I had that issue. I guess the way to do it, that would only require 1 branch per column per row. The cost of always starting at the very bottom, even if there's already a lot in these columns. Yeah? Screen shake, thank you. I'm glad you like it. Yeah, I don't know. So what I was thinking before is for each of the columns. I mean, well, because again, it's not just the highest spot. Well, yeah, it's not just the highest spots because of the overhang, you know. And if I want to like store multiple highest spots in each column, that just gets more complicated to figure out what the highest spot is, right? I'm tempted to freaking program each of these pieces separately. Start at bottom. For each column, check if there's anything in this row. If so, sorts Y for that column. Stop when you reach the real piece. Then the per column value to store the highest Y below the piece for the last column. If there's an empty spot lower, then you have two or more spots for each column. No. Start at the bottom. For each column, check if there's anything in this row. So stores Y for that column. Stop when you reach real piece. I mean, I'm not sure that starting from the bottom or starting from the top will really change much of that. If there's open spots between the taken ones, it would still save the highest one. So what I'm thinking with this other way around, thank you for the follow, by the way, appreciate that. Where I'm checking the rows, each row at once. If I get to a row where I determine, okay, we've hit the bottom, regardless of what the other rows are, we are now at the bottom. I can abort early. And I suppose it won't really help too much the worst case check, which is an empty field. Say the bottommost open spot. Would it? Well, yeah. If you're doing it that way, yeah. Well, checking for no. Checking for a piece rather for not a piece, right? To check both if that row contains something, if the column already has a value. Yeah, it still loops. This isn't nested, right? Oh no, this is a nested loop actually. Yeah. More checks per route. Yeah. Let's get back the line piece, because that is going to be the worst case scenario. This guy here, like that. That's the worst case scenario for this. Board contents and how tightly you can code them. Yeah. Yeah. Let's get a higher score here, or rather, I'm going to change the score and see where that how bad the highest score can be. Because I don't think I've done that yet. Not that. Not that. Calc score. Gotta love consistent naming. God. Score. Let's have a look at that in memory. 0, 1, 2. All right. We're just gonna make that F, 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 F. Highest possible score. And we're gonna go there. All right, where are we in the frame? I closed it. Event viewer, we're way up there in the frame. Okay. And let's jump out of. Oh! Oh, God! Oh, Jesus! Not too bad? That's just calculating the score! That's atrocious! Oh, you mean the RAM? Oh, yeah, that's something different. Whew. Yeah, I don't have that much memory, but yeah. So, yeah, I've got like 2K of RAM, roughly, but I've also got 8K of program RAM that I am going to be using. I haven't enabled it yet, but I will be using that for like high score stuff. So I will have like more space if I need it, but I don't right now. Yeah. Wondering how are you checking to see if a row is full? So for that, the maximum number of rows I check is 4, right? So the line piece is the worst case scenario. So I only check those 4 rows. I don't check all 20 rows. I only check 4 rows, and it's a very brute force. Load the cell. Is something in the cell? And I think I have an exit early on that as well. Check clear row. Check row something. Check row clear. This right here. Clear rows. So this is 20. All right. Oh, those are the rows that need to be clear. So that's just a flag, right? I don't know why these are incremented. What the hell? Oh, because okay, so it checks. Yeah, it checks for all of the rows in the grid. Now, check single row. That's this right here. I mean, I could take out the JSR on that, but start looking into modding Skyrim again. I was running the game without an FPS lock. GPU was having coil line. We got FPS that's a range of 4,000 to 5,000 FPS on the main menu. Careful with unlocked FPS on Bethesda stuff, because your physics are locked to that, aren't they? You don't maintain a bitmap of fill positions, which you will allow you to check a row in 2 compares. No. Even better, a bitmap of empty positions, which would be load break. Yeah, I don't. I did think of just counting whenever a block is placed. Add the block contents essentially to like row values, right? So right now every row has 0. If I were to hard drop this here, I'd just add 4 to the last row, right? So then this last row will have a value of 4. And then to check the row clear, I just check all of the, not all of them, those 4 rows for a value of 10, hexadecimal 10. Or the inverse with the empty, right? So it's 10 empty. I drop this, subtract 4 from that, and then I'd be able to go if there's no empty. So if it's equal, load A, branch equal, kind of thing, right? Yeah, I don't want to have to maintain a bitmap for that, you know, because I'd have to do a lot of shifts and crap for doing that, wouldn't I? Yeah. Yeah, I don't think I don't want to handle that, honestly. I mean, what I can do though is I can actually simplify this a little bit. So I can take out that call. Doink that, paste that there. So it doesn't do that anymore. Nope is going to go nope right there. Otherwise, load a 1. Branch equal to nope. Which isn't there, actually. Nope is just going to be next. That means I don't need this. I don't need that. So that simplifies a little bit. And that's the only place that's called. Let's make sure that didn't break anything, yeah? It did. It broke absolutely everything. Whoa, what? Uh-oh. 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 Yeah, he marked it. How did that bork it? How the hell? Okay, check row clear. And then okay. What the fuck, Tetris? Yeah, right? All right, let's do this. We're going to reload that. All right, our field starts there, ends there. You can see a bunch of 81s in there. Those are my blocks. All right, so store that there. Plus 87. 187, excuse me. 187 right there. 1, 8, 18, 7. What the hell? Why is it looking way over there? That should be looking like way over here somewhere. What the hell? How? Huh? How did that break it? Is it -6 quite normal for January nights? I don't know. Depends on where you are, I guess. Okay, all this was is I just copy pasted that thing into the repeat. Yeah. I might want to get my debug board back in place. Actually, you know what? Let's change the debug board a little bit, so I can a little bit easier see some stuff here. So just fill that in, and I'm gonna take this piece like that. Okay, it's gonna be at the beginning of the row. So the first row, yeah. So the first one it checks should be a fresh block, right? Okay, and I want to break on the do a hard drop. Go there. I'll break on that. Like that. So I can come over to here, redo that. All right. So that cleared out the read history. All right. Drop shaking up. Place block. This one should place block there, 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 and there. Gonna jump over this. Good. It placed them where I wanted them. Now I'm gonna go into here. All right, so this just clears out an array to see what rows we need to clear, which fine, whatever. Let's get rid of that block Y. Let's no, not I want that U 17. Sure. There's 20 of those. All right. I could probably consolidate that down to like 4, honestly, but whatever. All right, put that there. Decrement. Branch minus. It's not too high. It's not too low either. Combo. Uh-oh. That ain't right. Block to playfield is wrong. Our Y is 13. Okay. Block to playfield. Board height. Do I need that +1 or something? Board height is 20. 14. It's in... Okay, so it's in that lookup table. (0376). Is that the start of the field? Yes, it is. The end of the field, right there, 43E, 43D rather. What do we go up to? 3-4. I don't reset. Why? That's why. I was forgetting to reset. Why? Yoink that. I saw that as load A0. Next. That's why that broke. All right. Let's try this again. There we go. That's better. Make sure I didn't break it again. I did the same pattern that I did before when I broke it. Come on. Good. Fantastic. So I think that took off a little bit on the what's it? On the calculation. The next elephant in the room is score stuff. Because that can take forever. And some of those, like combo, I'm never going to be using... I'm only using like 1 byte for that. So I don't need to go higher than 256. I don't even need to go higher than 24. Or whatever the hell it was that we found out the other day. So I might just put that in a lookup table and max out the combo at a value, right? If it goes over that, no, you didn't. No. Wasn't one of them. Yeah, I know, but yeah, I think I could completely break the ghost stuff and all that. But I don't really see it getting that much faster, honestly, without completely breaking it. And I just fixed it the other fucking day. So I don't want to get into that bag of worms right now, okay? So yeah, let's clean up that. Yeah, so we're gonna clean up the score stuff a little bit. Calc score. All right. Where's the combo thing? Level math done. No combo. All right. Combo. Load that up. If that is 30, we're going to set it to 30. If that's greater than or equal to 30. Greater than... If it's less than 30, we're not going to do anything. Branch carry clear. Or, we still need to do that, actually. Yeah. Combo just has... Combo tiles, combo res 1. Combo tiles, that's going to be res 2. We're only doing 2 of them. Is that DWM? It is not. It's XFCE. Welcome, by the way. Tails Monster. How you doing? Yeah, so for that, combo, tiles. A and B. Wasn't the problem in converting the score to decimal, not in adding to it? Yes. This right here, combo, is going through that bin to decimal stuff. But if the combo can only go so high, I'm not going to send it through the bin to decimal slow crap. I'm just going to make some lookup tables with 30 values that I just look up real fast and skip the whole math stuff for the conversion. Yeah? Yeah. So, it's for displaying a bunch of things. It's for displaying the numbers, all of them. Combo, score, lines, and the level. Not the high score, because that's just something static from the, like, whatever. But yeah. Bin to decimal small, right there. There's 2 of them. More than 2 of them, I think, actually. So there's the combo. The score that does the bin to decimal. The lines that also does the full bin to decimal. Because that's total number of lines that you've cleared this run. And then there's a level, which is the smaller one. So that happens a bunch. It's called a bunch. And the first one is combo, which I believe we determined last weekend that the highest combo is like under 50, like 20 something. Yeah. Why does it even matter to limit the combo stuff? Chisel away at little things. Get it not running through the bin to decimal stuff. So that's one less thing that goes through there, right? One less thing that goes through all this stuff, which is the loops and subtractions and increments and all that crap. And then for the stuff I can't do that with, I think I'm going to try... where is it? I might try to implement this right here, which is another algorithm for converting a decimal number into BCD, which from there is rather trivial to get into tiles, right? Because I just take 1/2 of the byte, make sure it's in the low nibble, and then just or 30 onto it, right? Now, excuse me. Yes, for displaying the current combo count. Yeah. adding the combo score into the total score, then displaying the total. Nope, no, it's for actually drawing the number for the combo, right? So it's for drawing that actual number there, taking it from the decimal representation of it into the I'm sorry, taking the binary representation of it and converting that to ASCII essentially. Yeah. And yeah, the lines and the level, I do need to. I can't use the same method I'll use here. The level, that's going to go up. I don't know. Sure, maybe 9,000 levels. Who knows? Well, maybe not for level, but for lines, that one I can see getting kind of high. I am terrible at this game. I can get over 100 lines, level 12 or 13 before I crap out, right? Depending on how many bad decisions I make. But I'm not a great player, right? Feeling the combo is always below 99. Some lookup table can do the pin to BCD. Yeah, so I think someone pointed out like last week that the highest theoretical combo you can even get is like 27 with like a perfect setup on the board or some nonsense. So I figure give some buffer, right? 30, screw it. Or 40 or whatever, I don't know. Give it some buffer. And then I won't worry about it. Because at a certain point, it is physically impossible to get another combo, right? 32, hell yeah. Oh, whatever. Before that, a game... All right, the tiles. I want to just make I just want the tiles straight, so not even like need to do any conversion crap. This is tens and then ones for that. Do I want to do this by hand? Not particularly, but bite 0. Repeat. No, bite space. Repeat 10 times? Sure. And then bite 1 another 10 times. And bite 2 another 10 times. And bite 3. Do that twice. Why not? And then here, repeat 10, I. That bite, let's, so I can like see that a little bit, right? This is going to be 30 plus I. Right? One, 2, 3. 10, 20, 30. Zero to 10, 10 to 20, 20 to 30. No, don't repeat. Bite 0. Bite 1. 0 plus I. I can do that. And now, load Y combo. Get rid of all that. Get rid of that. Combo tiles plus Nope. No. No. Load A. Combo tiles A at Y. Store that into combo tiles plus 0. Nope. No. 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 Come on. F. Oh, F, A, not B. I'm looking for B that doesn't exist on that row. Okay. And then plus 1. Combo tiles, res 2. 6. Make. I think. Okay, I do all right, that's good. I do the length of start. Combo is not right. Because I draw the zeros there. That's why. Ah. What am I going to do when I finish the project? I don't know. I'll work on something else then. This isn't my, first NES project. This is... I don't even know what... I've lost count. I've lost count of what project number this is. All right, so we're going to go over to... Where is it? Here. Play field. Combo 0. Just going to start there. Do that there as well. I think I want to not pad these with zeros to start. Same project 69. Yeah, sorry. Sorry, this isn't project number 69. That's a little weird, the way it's got it there. Combo 0, yeah. It's doing it weird when it's not -1. Oh, because when I clear that out, it's I do that. No. Instead, load a nothing, store that plus 0. Load a 0, store that there. Okay. Well, that ain't quite right. How the hell did I screw that up? Did I get the address wrong? $8.19. Oh, yeah, there's that. Thank you. There's +1 there. And also, yoink and init. Like that. So it starts correct. There we go. All right. All right. Let's get a few combos ready here. All right, so that's 10. So let's get one more. So that'll be 3 combos. Three. 1, 2, 3. Good. All right. Good. Good. Okay. Let me actually at least commit that. That and the that single row stuff right there. Yeah. Partial. Yes. Playfield ready. You know what? Yeah, we'll do that as well. We won't do that. We will do that. Not gonna do that. Yes on there. Yes there. Ooh, we're gonna edit that. Not do that. Your edited hunk does not apply. Hit edit again. No to discard. Edit again. Yeah. Why doesn't it? Oh, because yep. That's why. I'm gonna edit that. Like that. This one, yes. Sure. Yes. Why not? No, no, yes, no, no, yes. Edit that. Get rid of that bottom line there. Okay. All right. Commit. Some timing cleanups? No. How some speed improvements. Unroll some clear row checks. Only redraw the play field when it updates. And don't use expensive. That's under contract files that you. Oh, I do that every once in a while. Been to decimal routine for the combo value. Use a lookup table instead. Oh yeah, I see it. Yeah. Yeah. Okay. I do still need to check for out of bounds on that, but screw it. I don't know. All right. What's this one? Level. I think I might want to see if I can get this figured out, maybe? Nothing critical? Yeah, nothing critical, really. Maybe. Complication, yeah. This allows the shift to NAT3 algorithm can be implemented using a small number of gates and computer hardware, but expose high latency. I'm not too concerned about that. All right, suppose the original number to be converted is stored in a register that is n bits wide. Reserve a scratch space wide enough to hold both the original number and its BCD representation. N plus 4 times the ceiling of n divided by 3 bits will be enough. Sure. It takes a maximum of 4 bits in binary to store each decimal digit. Yeah. Then partition scratch space into BCD digits on the left and the original register on the right. For example, if the original number is converted as 8 bits wide, the scratch space would be partitioned as follows: hundreds, tens, ones, and the original. Diagram above shows the binary representation of 243 in base 10 in the original register, and the BCD representation of that and on the left. Scratch is initialized to all zeros. Then the value is converted. Then the value to be converted is copied into the original register space on the right. The algorithm then iterates n times. On each iteration, any BCD digit, which is at least 5, 0101 in binary, is incremented by 3. Then the entire scratch space is left shifted 1 bit. The increment ensures that a value of 5 incremented and left shifted becomes 16, thus correctly carrying into the next BCD digit. Essentially, this algorithm operates by doubling the BCD value on the left each iteration and adding either 1 or 0 according to the original bit pattern. Shifting left accomplishes both tasks simultaneously. If any digit is 5 or above, 3 is added to ensure the value carries in base 10. The double dabble algorithm performed on value 243, base 10, looks like this. Shift, shift, shift. Add 3 to 1s since it was 7. Shift. Add 3 to 1s since it was 5. Shift, shift. Add 3 to 10s since it was 6. Ah. Shift, shift, shift. I see. I don't know if that'll be any faster. I mean, it could be. So I need to do rotations. And I need to do this across fucking so many bits. Oh my god. Using this in 652 myself before, but found it to be slower than I liked. But I think I had other options that were faster at the time. So I'm not sure if this is slower than what you have. Yeah, this. So I have 24 input, but 24 bits as input. So for each single shift here, that is 3 rotations. Yeah, so I got to rotate it off the first byte, onto the second, and then onto the third, and then onto the ones, and onto the tens, and onto the hundreds. But I could keep all those as, well, no, I can't keep those as, as individual bytes, so I do need to keep them as 1 byte. So I will need to split those afterwards anyway. All right, well, let's... Let's see about implementing this. Let's see how terrible it becomes. Bin to des shift. Okay. Per segment. pop segment. I want 0 page for this. 0 page. All right. BCD input. Res 3 BCD output. Res something. 24-bit. How large is that in decimal? So 1, 2, 3, 4, 5, 6. A lot. 3, 6, 7, 8. I currently have 1, 2, 3, 4, 5, 6. I could possibly do 8, actually. Screw it. Let's have it the full 8. And we will convert that to what's it? ASCII in this. So res 8 for the output. BCD scratch res 4. Yeah. Okay. So this is going to be ASCII BCD. Bin. All right. Okay. So, repeat dot size of the scratch at I, load up 0, store A into that plus I. We'll deal with the other ones later. Okay. Then it iterates n times. What is n again? N is the number of bits, right? So it'll iterate 24 times. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3, 4, 5, 6, 7, 8. 8. Okay, so we'll have 24 sets of rotates. Ew. And in between each of those, I need to do a compare to 5? All right, so clear carry. Rotate left. Yeah, on each nibble too. Yeah, not each bite, each nibble. Yeah. Rotate left. BCD input plus 0. Rotate left. BCD input plus 1 and plus 2. And then yeah, so I do a full set of shifts and then the additions. Rotates, excuse me. Plus 0. 1, 2, 3. Oh my god, this is going to be expensive. 1, 2, 3. So I need 24 of these. 24 sets of just that. And then the compares. Holy shit. ASL, well, I'm keeping it uniform for now, all right? Give me a break. All right, then we're going to load up BCD scratch plus 0 and that with 0F. Checking the bottom one. Comparing that to 5. Carry clear plus over there. Clear carry. Add carry 3. Store that there. Two. No, not 2. 1. 1. 2. 2. Shit, no! Oh my god, this is going to be so much more expensive, I think. Compare that to Hex 50. Add carry. Hex 30. Shit, no. Oh my god, I gotta... I have to OR that with the bottom half. Carry into the other base reach in addition to, I think, as in case of overflows. Yeah, oh my god. So I need to do the add 0 to... Oh, Jesus. Okay, so this is for both halves of that nibble. So if I AND it, I need to load that up again. Load it, add 3, store it back. Load it, add 30, store it back. Load up the next, add carry 0, store it. Am I correct here? And this is just for 1 byte. I need to do this 4 more times. That's disgusting. That's disgusting. Oops. Paste it there. 1, 1, 1, 1, 1, 1, 2, 2. Do you need to carry all the way into BCD Scratch plus 3? And also for the first edition. So the first edition here, this will carry into the high nibble. That's what this add carry does. It is the overflow into the high nibble. This one well, yeah, wait, is that, hang on. I think anybody who's at least 5 in binary is incremented by 3. The entire space is left shifted 1 bit. One bit. Not sure if that's possible, though. I don't think it is. It should never be able to get that high. Because if it hits 0101, we do some shenanigans with it. If it's at least that. So if it has 111, because we're shifting in like one bit at a time, so that shouldn't be possible to hit F anywhere. In theory. All right, well, let's just continue with this here. Hang on. Ones or 1 10 100 1K yeah. Yoink. Paste. 10K. 2. Oh, no. 2. Come on. 2. Thank you. 2. Nope. 2. 2. 2. 2. 3. 3. For 100K. 1, 2, 3, 4, 5, 6, or let's 10 mil. Okay, we're going to 10 mil. Right? Because I have 4 in the scratch. All right, so I've got like I gotta do this 2 more times. Well, 1 mil. Three. Oh no, it's plus 3. So that's number. This is the last bit, the 4th bit. And this is 10 mil. And that is a single of the 24 iterations. Fuck you. Holy shit. That's disgusting. Overflows by 2,000 bytes. All right. Let's see if we can put this somewhere else. I'm going to yoink that. And we're going to put it at the end of there. And then we're going to just comment all that crap out. Okay. Gotta love the unrolled loops, right? Over here, reload that. Oh yeah, that's a lot of code it's generating. Jesus Christ. What the hell did I name it? I didn't fucking save this. Okay, it didn't overflow. Bin to decimal underscore shift. All right, let's have a look at how big this is in the memory viewer. Oh, that's disgusting. Oh my god. Oh my god. There's no way in hell this is faster. There's no way in hell. Okay, we're gonna get a current cycle count for the score stuff. Calc score. This one here. Okay. All right. Step over. 280. Let me hang on. No. I'm gonna make it worst case scenario. So we're gonna make that. All right. View memory. Score F. Okay, we're gonna do that again. Okay, 14,000 cycles. 14,117. Where is it? Where is it? Undo that. 14,117 cycles. And score is only 3. Yeah, okay. Okay. Make. Didn't use 0 page for BCD input. Why not? Where? 839. I want to use 0 page for that. Oh, but so we can force that. What's the Yeah, it's before access before I declared it. Well, I mean, I can just I'm gonna put that right here just to be anal about it. Make. Okay, now it used 0 page for that. Reload. And go to location. There. We are gonna hit. Well, let me change the score value first. Go to location. Not location like that. No. Go to that location. This one. View in memory. 1, 2, 3, 4, 5, 6. Okay. Now, how long does this take? Are you ready? No! It's faster! By an order of magnitude! What? 7,279. What? It's all zeros. Why is it all zeros? It didn't do anything. Score is 0. Why is score 0? F. Oh, because it might have recalculated some stuff. Pop. No. Step out. Okay. Now I need to find where that is. I don't know where. Scratch. That doesn't look right. Go to location. No. $7K. Yeah, something's wrong, I think, though, because I don't think I have the right values out of this. Scratch. So the scratch should have not the ASCII, but scratch plus 3. That should have 16 mil in it. So that should be 16777215. And it doesn't. Something's wrong. That said, if I'm just like missing a thing here or there, 3,000 cycles from, or, well, no, what was it, 3,000 or 7,000 cycles? Somewhere around there is still an order of magnitude faster. And handling more digits. Yeah, I shouldn't have A's in it. Yeah. So something's wrong. Something's wrong. I don't know what. Go back over here. It'll load score. Okay. Oh, yeah, I don't actually update the ASCII stuff. That's whatever. Okay, so we're going to see what happens here. So we clear out the scratch. Clear carry. Let's also get rid of that stuff. I don't care about the current block. BCD scratch. Let's actually have a look at that. I need 4 of those, but binary? Yeah. Have a look at that in binary. Can you, like, get wider, please? Messin, please. Please, Messin, please. I don't care about the call stack, because whatever. 1, 2, 3, 4. Let's BCD input 3 binary. BCD scratch 4 binary. 16 is high byte, but still shouldn't have. Yeah, you're right. There shouldn't be any A's in there. All right. Rotate, 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 rotate. Load that, and it, compare, carries clear. Correct. Load that, and it, compare, carry clear. These are all going to be carry clear because nothing's in them yet. Clear it. Rotate, 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 rotate. 3. 2 more rotates. It's not 5. All right. Rotate. Rotate, rotate, rotate. That is 7. So, carry is not clear. We're going to clear the carry. We're going to load 7. Add 3. Store it. There's that A. But after the next shift, that'll overflow it into the next one. After that shift. Do I need to do like one more shift? Is that what's happening? Am I not supposed to be... Hang on. Hang on. Repeat this 23 times. And... yoink that. Paste it there. It's still only shifting 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. So we're gonna. So I removed an entire one block of the compares and replaced that with just the shifts. We're gonna see what that does real quick. Over here, reload that. Yeah. A. View memory. F. Okay. One. Three. And here, that makes it 7. I did the add. So the next shift should carry over. That's no longer A. That's not a good sign right there. That's a bad sign. That means we're at the beginning of the next goddamn frame. Don't trust that timing. Don't trust that timing. Because I think I calculate scores out of sequence somewhere at the very beginning. RTI. Yeah. Actually, slower. I don't believe so. Not Kemi. How you doing? Welcome. All right, 15. Compare it. Carry's not clear. So we're adding 3. Makes it 18. Stores it. And then that will shift on the next. So it overflowed. No, it carried correctly. Yeah. The look would be too low. Yeah, it's because of it's the very first frame in the game. It's in a weird spot on the refresh and all that kind of shit because it was coming from the main menu handler. So it happens in a weird timing. Yeah. Test instruments for assembly? What do you mean test instruments? I feel like you have an assembler. Yeah, right? All right, so these are all going to be okay. 63. 3 is fine. 60 is not fine. Load that. Add 30 to it. Store it back. Load that. Add 0. Store it back. Load it. End it. All right. And then this. Where's the last shift? I want to put a breakpoint there, so I can just jump down to that. Oh my God! There's so much of it. All right, so last shift. One 157277716. Holy shit, that's right. The bytes are backwards, which is fine. 16 77 72 15. 16 77 72 15. Holy shit. Let's go. Amazing. Okay, so let's there. We're gonna put another breakpoint right on that, or so that. Okay. Let's get a few frames in. Okay. So we are at, where are we at in the frame? We are way up there in the frame. All right, we're gonna jump over this. 3,246. 3,000 cycles? What? Excuse me? Up from, what was it, 14? 14,000 down to 3. 10,000 cycles faster. For another digit even. All right. So let me actually, okay, so now the only part I need to do now is take this and split it up into the ASCII stuff, which that's going to be like pretty trivial actually. All right. Make it ASCII. So we're going to load up BCD scratch plus 0. We're going to AND that with 0 is the low one, right? Yeah, so we're going to AND that with 0. Let's go the other direction. Start from 3, work our way down. AND that with F0. I don't care about the AND. LSRA 4 times. OR it with 30. Store that into BCD output plus 0. Yoink that, paste, and it with 0F, or it plus 1, like that. Like just MocoJS or a PHP unit for, oh, I mean like unit tests. Since we're going to the emulator, we have direct access to the registers, etc. We can validate the results to compare. Without the emulator, we need to have access to memory registers by hand, which unless you happen to be the kernel, you can't without working on protections. Yeah, well, unless you write your own emulator, which I have done for the express purpose of testing an error case that I had trouble recreating. Is that first cycle count from a frame where it was interrupted by the IRQ? think so. Okay, a few frames in. We are currently after IRQ. Oh, I need to set the score to something something high. The score needs to be set to F because that's the worst case scenario for this routine. All right. 14,117 cycles. That is not including an NMI or a IRQ rather. So the old code exits early if it can, right? So the first time I ran it, ran through 200 cycles because it had no digits to do anything with. The new code is linear time. So it like for the small numbers, it's you know not great, but then once you start getting to the high score values, it's a lot better. Like it's order of magnitude better. Yeah. So we're keeping that. What did I say it was? Like 3,000 something? Make. Yeah, so we'll do this a few times. And then. Yeah, so even with zero's input, it's still, well, 2,000 cycles, I suppose. It'll vary a little bit. Because of the overflow stuff. It's not quite fixed time, but it's much closer to it. Yeah, this is 2,000 cycles. 2,000 cycles. The other one was roughly like 3,000 something. So I'll say roughly 3,000 cycles. Yeah. Colon W does nothing over there. Yeah. Okay, so for this, making it ASCII. Start it there. Then we want yoink, paste 2 and 2. This is going to go to 2 and 3. I'm not checking before the first couple shifts since it can't be 5 yet within two bits. Sure. But even then, I'm not really worried about it now. Let me get this out to the screen here. 3, 4, and 5. 3, 6, 7, 8. So I need just one more. Right? Did I added 1 to that. I needed to subtract 1 from that. Okay. So 1, 2, 3. And then the last scratch. Yoink. Paste. 0. Nope. 0. 6, 7. I'm off on one somewhere. 0, 1, 2, 3, 4, 5, 6, 7. 2, 4, 6. It's because there's 8 digits, not 7. I can count, I swear. The old approach could have been optimized a lot more for large numbers too. Connor Sweeney, how you doing? Are you using Make for builds and VS for debugging? Not quite, no. I haven't seen Makin VS in the same project before. I'm not using Visual Studio anything or VS Code or whatever. I'm using Vim and Make. What you're seeing over... Where's my debug window? Here, this is Messin. This is an emulator, an NES emulator. Fantastic emulator. Banana, how you doing? You're making the game Tetris? Yes, like the game Tetris. Let me turn off that, and let me turn the speed back on. And you know what? Let me turn off some debugging stuff real quick. So let's turn off. Where is it? The debug piece and the debug field and debug flash. What the hell is debug flash? Oh, okay, I know what that is. That's the piece flashing. Yeah. So yes, I'm writing actual Tetris. Hey, no banana, by the way. And the goal with this, by the way, is to bring in some modern Tetris features to the NES. Things like a hold piece. You hit select to swap it. Proper RNG. So I've got the bucket system where the next 7 pieces are one of each of the possible pieces shuffled. I've also got the ghost piece that you can see there. It doesn't look great with the white background, but I've got the white background so I can do some profiling stuff. That's what this nonsense is, to see some timing. I volunteered to test it. I don't have a ROM available yet, but probably actually this weekend I'll make something available. Yeah. Looks a lot like VS with a different color scheme. Yeah, I don't use VS Code. Yeah, it's been a lot of I've been making like a lot of progress on this, like an eerie amount of progress. It feels really weird. Really weird. Like within like the first 2 weeks, I had the proper colors working. So the notable things with the other Tetris games on the on the Famicom or NES. Let me load them up real quick. No. Where the hell? Where'd I put these? Where's N? No. ROMs? Nope. NES ROMs. There it is. And then let's go Famicom T for Tetris. Let's copy that. I'll bring this over here real quick. Open. How dare you? Okay, can I click and drag maybe into this? Tetris. Not Tetris 2, not that stupid game. This one here. Really? Really? I can't click and drag. That's stupid. Open. Bubba. Can I at least paste it? Really? Why is this being a pain in the butt? Copy the full path. Go over here. Paste the full... There it goes. That's not... Give me a second while I wrestle with my operating system here. All right. All right. So, do I have... I might, let me make sure the audio's off. Do not enable that. Okay. So this one, and I'm running full speed, right? Yes, normal speed. Start. You'll notice that the pieces are all a shade of blue, kind of, right? Blue or teal. And there's no hard drop. There's only soft drop, right? So all the pieces, you know, they don't have their proper colors. The other Tetris game on the NES... open and bulletproof. What is this? BPS. Is this what I'm thinking of? This doesn't look right. This is not right. This. Oh, okay. I forgot about this one. This one's also crap because it doesn't. Apparently. Ew. Wait, how do I? Oh god. Hit down to rotate. Hit A to hard drop. That's disgusting. Oh my god. Oh Jesus. That's not the one I was thinking of. The one I was thinking of. That one. There it is. Was. Hang on. Oops. This one right here. This one. Tengen's Tetris. I hate this version. Boo. Yeah, they're not great. They're not great. And then this one, again, no hard drop. It has soft drop. Once the pieces hit the ground, they change color, right? So, like before, like the active piece has a color. It's not the correct color, but it has a color, right? But also the RNG in these are garbage, right? I hit escape to pause the hardware. That doesn't work that way. Okay. But yeah. So I am bringing some. Oh my god. It doesn't even see the file I had opened before. That's so stupid. Oh my god. This is annoying as hell. Code. Ness. Where's the Tetris one? There. Bin Tetris. There we go. So yeah. So I'm bringing in a bunch of the newer, the more modern features back to the NES. Press escape to pause the NES. Just try it. Yeah. Yeah, the ultimate version on the NES. That's the plan anyway. Yeah, I am using a much more advanced and expensive mapper. So yeah, I am pulling some bullshit with the colors. I'm not gonna lie. Let me get the black background again because that actually looks decent. Where are my palettes? Where are they? There they are. 0F, 0F, 0F. Make that again. Go over here, reload. There we go. So yeah, I actually have the proper colors for every single piece. And they stay their color when they hit the ground. All right. Tetrio default coach is the only valid Tetris game. I mean, I can only get so close because even though I'm pulling some shenanigans to get the colors, I only have a limited set of available possible colors that I can use. Like this right here, this is the full set of valid possible colors. Why can't I zoom in on this? Whatever. So these are the only colors I can use, period. I can't use anything outside of this selection here. Yeah. The real question is, can you pull different bullshit to get the colors on a cheaper mapper? I don't think so. I don't think so. Is there any other mapper that does shenanigans with colors like this? So basically, what I'm doing is I'm normally for the NES, a block of 4 tiles. So like this yellow block right here, is the same color, right? That's like the resolution for the color, right? What I'm doing here is I'm pulling some bullshit so I can assign each individual tile its own palette, right? If you've ever seen or played the game Super Mario Bros. 3 on the NES. When the screen scrolls, you'll see some like color artifacts on the side. That's due to that limitation, because you can only update the colors for the tiles in chunks of 4, essentially, right? Or rather, each chunk of 4 tiles can only be 1 palette. Yeah. Via dithering, which is its own can of worms. Oh, yeah, that's its own can of worms, all right. Do some really weird palette swapping nonsense. I'm not even sure how I would accomplish that, really. Yeah, it'd be jank as hell. It'd be real jank as hell, if anything. But yeah, so I'm able to, pull some nonsense. And have some animation stuff in there. The hard drop, and I got the button repeat repetition thing going on. Combos work too. Level system works. It does speed up. Select that one. So it will actually get faster. What? Oh, that's the. I'm going. What's with the color? That's the emphasis bits. That's on there. I don't know if you can see it, but yeah, it's actually it is still running that, but yeah. Yeah, no worries, but I'm excited for the progress on this. Honestly, this is I haven't had like this steady of progress on a project in a long time. I was thinking of spatial dithering, not temporal, but still be quite limited, even if you didn't need quite so many on. Yeah, it's because I need so many on screen at a time. I need to be able to display all of the colors at once, right? So these are the colors I'm using here, right? So the top 4 rows. So 1, 2, 3, 4. Those are the rows that I have for the background layer, which the entire playfield is being drawn in the background, with the exception of this active piece and the ghost piece, right? So if I open up the sprite viewer, and oh, good, it shows it correctly. These are the only sprites on screen. So it's the ghost down here, and then the actual piece up there, and that's what these colors down here are for. To derail everything. Well, no. So this isn't really derail, right? This isn't really being derailed because I'm still on topic. Yeah. Yes, this is all in assembly. Yep, this is all in handwritten assembly. That's what all this is. And today I just finished actually taking this algorithm for converting a binary number into what is it? Binary coded decimal? Is that what that stands for? BCD? Oh, it's literally right there. Yeah, binary coded decimal. And I just at the end of that right here got that into ASCII essentially. That's what this nonsense over here is. That expands out to 2 kilobytes of code, which is a lot of goddamn code. Like all that code, I'll show it to you over here. So this is the memory of the machine, right? If I go down to my actual code here, yeah. So these are different like code blocks, right? Like that's a table of coordinates. What the hell is this? This is some init code. All right, so that's the start of the frame right there. The bottom of the frame is somewhere over here, actually. I think. Hard drop, do drop. No, soft. Hard drop done. Yeah, okay, so the code that runs during the frame is right there. That's the main game loop, right? So the button detection kind of happens in here. I jump out to routines and whatever. But that's like the main block of every single frame that runs, right? Now, the code that does the conversion. The hell is that? Oh, that's some more net code and unwound stuff. That does the conversion from binary to decimal. Oh, that's unrolled for drawing stuff. All right, Q, hold stuff. Let me actually scroll down to the end of... All right. That starts there. Goes all the way down to there. 3,000 bytes. Apparently, I was off by a little bit. What compiler optimizations? Yeah. Yeah, for the NES and Famicom, the vast majority of stuff is in assembly. Some of the newer stuff that's being written is in C, because you can. I mean, the suite the software suite I'm using is the CC65 suite, or the C compiler suite for the NES. I'm using the assembler and linker from that. But there's overhead for it, so it runs slower, like significantly slower, or it can be significantly slower. Yeah. It says the one that's most among the people that's most responsible for joining exchange. Yeah. Yes, C on the NES has a significant overhead. Yeah, because the processor on this thing wasn't designed for C. Wasn't designed as a target to C. It was designed to have handwritten assembly. Have assembly handwritten for it. Yeah. Yeah. Compiler optimizations are always just as good as the compiler dev implemented them. Yeah. Yeah, and a lot of stuff just doesn't apply for this architecture. You know? An optimization that you can do in x86 just doesn't exist here. You know? Yeah. C also wasn't designed to work on an S. Last I checked, it's not a PDP-11. It's not a PDP-11. You are correct. You are correct. All right. Oh, you know what I'll want to do? Well, I'll figure that out later. Actually, did I get this? Did I get the score updating? No, I didn't. Right, because I don't copy the score over out of that. JSR to bin to that right there. This. Not bin tiles. I want BCD output to score tiles. And score tiles. Tiles. 6. We're making that 8. We're adding 2 more tiles on that, and that's going to overwrite some other stuff, but I don't care. It's fine. Make. Come back over to wherever the hell it was. Up top. Reload that. Oh, yeah, look at that. Why are those zeros? Am I not? Size of bin tiles. Okay, well, there's the problem. BCD output. There we go. There we go. That's better. Oh, okay. I'm bad at this game, in case you couldn't tell. Yeah. Really hard to notice the difference between those machines. The main difference is that the NES is just slightly smaller. No. This code is faster enough that you could probably use an actual loop instead of unrolling it, but unless you end up needing that space for something else, yeah, I don't really need it for anything else right now. And I am wasting so much space. This right here, this is a screen, the playfield screen, right? Just uncompressed. The entire 960 bytes of the playfield screen, completely uncompressed. So there's plenty of room for space optimizations, and even without the space optimizations, that's all unused right there, right? We go up to, was it E? Yeah, E is where the static code is, right? The non-banked stuff. So this is a static bank right here. Oh, that's what the hell is? What is that? Fill screen. Yeah, okay. Oh yeah, the utility stuff, right? That's actually kind of getting a little close to that. No wonder it didn't fit. All right. All the menu stuff is up here too. But yeah, again, uncompressed. So like, there's some really basic compression stuff that I could do for this. Some run length encoding stuff. Where like, perfect example here, right? 0F. All right, I've got 65 of them. So like, first byte, 65, and then the next byte is the one is 0F, right? So the idea is, all right, we know how many times we need the next tile, the next byte. Know the next byte, all right, do that 65 times, right? Yeah. And then when you get to like, you know, the end, just 0. Okay, well, we're done. Null terminate it. But yeah. Interesting looking chips. Oh boy. Yeah, I don't have the JS turned on. These things right here. That's a board. What the hell's going on there? Thank you for that follow. Appreciate it. We heard you like chips, so we put chips on your chips so you can compute while you compute. I don't know. Dip breakouts are smaller chips. Yeah, like what even is going on with this? Like, there's not that many pins on the dip. There just isn't. So where? Huh? How does that work? I don't get it. I love the aesthetic of this. The freaking like switchboard thing. I love that. There's actually a bunch of like Raspberry Pi projects out there that like have this as a face panel and then just like emulate the PDP-11. Yeah. Chips on chips. Just see. Well, yes. But it's less of like, you know, a full package on top of another full like package, right? Usually it's like more than one die in a single package, right? Usually. That's what the NES is. It's for the CPU. It's two separate cores in one package. It's the CPU core and the APU core, the audio core, in one package. All right. Oh, did I? Yeah, I tested that out, right? Yeah, okay. It's actually doing all the scores. I am not very good at this. Breaker boards are fairly common on prototyping, right? Chip replacement parts. Yeah, all right. That wasn't a great spot for that, or that really. I'm not even getting to the point where like this would get faster. I'm just like clean up. So much cleanup. Not really a good place for that, so I'll put it there. There we go. That's better. But yeah, scores at 4,000 now. No. I can tell you these 15 breaker boards were sitting in production for years. There. Let's put that there. Whoop. There we go. Nice and getting there. We go. We're getting cleaned up. $8,000 points. $9,000. Yeah, we're doing good. All right. So he does PCBs instead. Just look at the 1590 Founders Edition PCB. It's a small daughter boards. Really? Oh my god! Jesus Christ! That's insane. That density is insane. Is this like a daughter board? Because I see a massive connector here. Or is that for the extra power on it? D-box label. Do not touch! Do you want a PCB on your graphics card? You're right. Based on hardware products, using breakouts could be the easiest way to get things working properly. Yeah. 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 Still, that is incredibly dense. Incredibly dense. Is this all? Are these all just like capacitors on the surface? Is that what all those are? And then you got your memory chips here, right? What are these, like coils? Power regulation or something like that? Actually soldered to the chip. Yeah, right. Power regulation? Yeah. Yeah, like this block right here is probably all capacitors. Yeah. Nothing's labeled because why would it be? I mean, except for the big fat NVIDIA. That's labeled, I guess. Jeez. Ugh, excuse me. Where'd you fit the labels anyway? Yeah, it's good. Yeah. you'd have a hard. You'd be hard pressed to actually put the labels anywhere. Yeah. All right, let's move the this stuff up to over here. Okay. PCB stuff. Get rid of that. All right. Some below the chips, if they bothered, I doubt they bothered. I really doubt they bothered. All right, diff again. They only had a bit over 150 mentions of AI in their CS talk in 90 minutes. Oh, mentions per minute. Oh my god. Yeah, AMD. They were all trying to push it. All right. Excuse me. All right. Again, I'm not gonna commit the that calculation stuff or the profiling stuff. I'm not committing that. Yeah, I can't wait for it to just die as well. I think that just goes to the end. Yeah, that just goes to the end. Git add P. Yes. Yes. Sure. No. No. Yes. No. No. Nope. Yes. I'm actually just going to remove all that from the utils. All right. What's the point of having 120 FPS if 75% of the frames are generated? Yeah. Yeah, so it's the tech behind it I don't think is going to die. What I really want to die is the marketing hype around that bullshit where it's just plastered onto everything as like a buzzword. Oh, AI, whatever it does. It's like, I don't give a shit. I don't need a fucking chatbot and everything. Stop it. I don't need you to summarize everything in the goddamn program. I can read. Let me read. Get that shit out of there. So hopefully that'll die down. It's forced. It's fucking forced everywhere. Frame generation doesn't make any sense to me either. Yeah. MSFS, Microsoft? 2020? I don't know. Yeah, I hate the generative AI push for everything. The fact that it's being pushed into everything. Oh my god, fuck off. Just stop it. Stop it. Oh, more frames with no benefits of having more frames. I hate latency. Yeah, right? But number bigger. I don't really particularly like the upscaling either, but that's at least not as bad. I mean, I guess. I don't know. What did I change on the playfield? I don't think anything really. Oh no, I changed the combo stuff on the playfield, didn't I? Whatever, it's fine. Commit. Implement. What is it called? Double dabble. Did I close the window? Oh, I did not. It's right there. Double dabble. For been to decimal. Yeah. This is a much faster binary to decimal. Yeah. Currently only used for the score conversion. Whoop. Yeah. I would very much like to read the fucking numbers instead of just mush, you know. Oh, Microsoft Flight Simulator 2020. Okay. Got it. Kind of need those small things like altitude. Wait, hold up. Does it just fucking make up the parameters? It just makes up how high you are off the ground? That doesn't sound right. How do they fuck that up? Fancy temporal upscaling? It generates the next value, but since it moves fast, it's just mush. Oh my god, I see. Oh, I hate that, yeah. Wait, it generates the value, like it's doing that on like a dashboard? It's just making the number up on the dashboard? Is that what it's doing? Like with some AI estimation for how high you are? Why? I don't understand why they thought that would work. Yeah. Hey, no blacks, welcome. All right, let's get another one of these guys in here, like the lines. That one I'm not gonna do the full. I'm not gonna write the full thing to it. Yeah, size of lines. That's gonna be. No, the input's still gonna be the same. Like that. Shift. And plus. Two. That should work, right? Not been tiles. Lines tiles. And that will be BCD output plus 2. Make. Good. I got it lined up good. I got it lined up correctly, rather. Already kind of screwed up, not gonna lie. I'll get the 2 digits on lines. 7. $10. Good. Yeah. Like how it shakes when you drop it? Yeah, it gives it some weight, right? I thought about also adding in some like particle effects when you hard drop. So if I don't hard drop, if I like soft drop it like that, it just, you know, very light, you know, doesn't shake. If I just let it drop, it just, you know, it doesn't shake. But if I'm moving, you know, it's gonna shake. I'm moving fast. Moving fast. It's gonna. I like it. I like it. Yeah. So I still might add particle effects for it, like, you know, like some like little sprites, 3, 4 sprites or whatever. Just, you know, moving fast as a shake. I don't know about that. No. Yeah, it's always the managers that push that shit. I pushed back very hard with my manager, or the CTO, very hard. I told him, like, because he wanted to like start using ChatGPT for like writing code or converting code, and I told him point blank that I refused to work with AI generated source code. I told him, no, I will not. Point blank. No. And then he tried to still, like, you know, convince me that it's good. So he asked for Shaksta, how you doing? He asked for some old like PLB code that's just like to convert into fucking Python or something, right? So I took some egregious code that is live, right? And I gave it to him. And one of them, so at work, we print checks, right? So there's a big chunk of code, but big chunk of logic to figure out the layout of the check for a handful of different customers, right? So the program is for a bank. That bank has customers, right? And so we run one file, but in that file is the bank's customers, right? And they lay stuff out different. They have different names in different places and different like locations for certain things and memos and whatever. So it's a decently sized chunk of very customer specific code, right? So I gave that to him to have him feed into ChatGPT because I knew he was going to do it. He didn't tell me explicitly, but I knew he was going to do it anyway. So he sends his code back to me, right? That it converted. It does some bare bones like, load this variable, load that variable, and then thought there were pointers, which there weren't. Don't worry about that. But the part that got me is towards at the bottom of the code that it generated, it had a comment. This said, the rest of the customer-specific code goes here. And I'm like, wait, hold up, stop. All of this was customer-specific. That's what I wanted you to do. And you gave up? Excuse me? I brought that up to my boss. I'm like, yeah, like this code didn't even do what I wanted it to do. Like the one thing I wanted to see the bullshit it would produce, it didn't even try. It gave up. It said, no, thank you. And you want me to use this? Absolutely not. No. Absolutely not. But unfortunately, the devs can refer to either the company or the actual developers. Yeah. If I'm going to be on the project thing I might be on, I project out company self-control. Your company controls. Push back if they do stupid stuff, but in general, atmosphere of the company is, yeah, it's going to come back and bite us in the ass if we do. Yeah. Yeah, thankfully, my boss has, after a few tries, he has walked back mentioning AI around me, which satisfying. The last time I heard about it, right? So we use this software suite to move files around. FTP, SFTP, Windows shares, bullshit. And he had insisted that this piece of this software suite exposed an API that I could use. That was a REST API. He was telling everybody on the team that this REST API existed for this piece of software. Here I am, looking through the documentation for any kind of API, anything. And I'm not finding any mention of API. So I'm like, so I email him, yeah, this doesn't exist. Like, I don't think this exists like you think it does. Like, can you give me, like, a reference in the documentation or something? Or maybe, like, are you talking to the vendor? Like a sales guy over there? Like, what's going on? Sends me back an email. And he copy-pasted ChatGPT output. I can tell because the code block things, right, have a little copy button. That was copied in the text and pasted into the email. Everything in that response, 100% of that response, of the API bullshit, whatever, was hallucinated. 100% of it. So I shot it back to my boss. I'm like, hey, you're wrong. This does not exist. And there's like endpoints in the documentation, the examples, right? Go to that endpoint using our server. 404 doesn't exist. take a screenshot in the email. No, this doesn't exist. Stop it with ChatGPT. Do you have any? I think I actually told him or asked. Do you have any actual documentation for this? Because the output from ChatGPT is useless. Do you have any actual documentation? And that was the end of it. That was the end of the AI bullshit he's trying to shove down my throat. I'm like, no, stop it. It's wrong. I was so mad. So mad. But anyway. Okay. I think over here. Oh, no. Over here. Load up. Score. Tiles. +0. Compare that to 30. 30. Branch not equal. Score, tiles, done. I want to remove the preceding zeros. Load up. That. Store it there. Yoink. Repeat 7 times. I.
Hacker man. He's the most powerful hacker of all time.
Thank you for the Prime. Appreciate that. Adrian? Am I saying that right? Welcome. How you doing? All right, let's see if that did what I thought it would do. So that should remove all the leading zeros except for the last byte. The last 0. Good. Oh, beautiful. Beautiful. Good. That cleans that up a little bit. Makes it look a little bit nicer once I rearrange some lines and crap and realign some stuff. But aside from that, let's put that over there, like that. Oh, I don't have a spot for that. Uh-oh. Making bad choices. Making some bad choices here. So many bad choices. Oh my god. Yep. Okay. What? I made some mistakes. We'll clean them up though. Okay. All right. There we go. Okay. We're back. But good. That's what I wanted. Okay. All right. At the lines, I'm going to do the same thing with the lines. Like that. Put that there. Score tiles. No. Lines tiles. That is just going to be 5. Like that. If you don't want to move everything around, you can just move that line back a column. Gives you a space. Right, yeah. By move things around, I mean like the actual lines on the grid here. So this is just debugging stuff, just so I can, line things up. I'll probably just have like one of these, like that. I'll probably like expand that out to there, right? And I might even like move this in, so it's uniform. I don't know. I'm not really worried about it yet though. But that's what I mean. I don't mean like moving the actual score values. If anything, I'd move the label, but I don't know. Make that was lines, right? Yeah, those lines that I did just then. Good. I'd want to like line up the stuff for all that as well. Oh, that wasn't really good either. Welp. Now it gets ugly. Yay. Oh, that's okay. Well, that's cool. That's cool. I guess that's. Oh God. Oh God. Oh Jesus. Oh, I'm making so many bad choices here. Oh God. Oh no. Oh no. Uh-oh. Uh-oh. I need that other line piece. Huh. Huh. I need another line piece now. There. Oh, that was the wrong spot for that. Oh, God. Oh, no. I'm so bad at this. I still don't have that clear yet. Oh, that was probably a bad spot for that. There we go. I got it clear now. That's not what I wanted to do, but sure, whatever. Yeah, sound's a whole nother issue, yeah. Jibity 4.0 can be helpful. It helped me a lot to understand websites this week. What proper tutorial help? Equally, yes. With the issues with the code, also yes. I mean, yeah, it can, but I mean, I don't like it being shoved down my throat, right? Moving the scoreline until we need to do that. Yeah, that's fine. Yeah, I was probably gonna do that anyway to move some, shuffle some stuff around. Well, producing what I saw, I can't generate shit properly. Yeah, as long as you understand that you can work with it and get some use from it. Yeah. It won't help you jack shit on specifics you can't. It simply can't know. Yeah. Yep. Did it help to play Tetris better while developing it? I mean, it does help to be better at Tetris when you're trying to debug Tetris. I'll give you that. Like I said, I'm bad at it. I haven't implemented kicks yet, or like T-spin things, like T-spins or any of that stuff. The SRS system, minus the kicks, is kind of implemented. I think I've got the rotations on that correct. But I'm gonna have a hard time debugging weird kick rotation stuff. Yeah. I should add in sound effects. So I want to as well. There's a lot of stuff for the sound that I also want to do. I've got ideas. I've got a lot of, and I have a lot of room to work with. So normally on the NES, there's only 4 channels, 2 square, a triangle, and a noise channel, plus some sample stuff that I'm ignoring. With the mapper I'm using, MMC5, the same one that I'm getting the colors from, this allows me to do that. It also adds an additional 2 square channels. Right? My sound, like from my mouth? No, that ain't happening. I ain't doing that. We can even calculate the coefficient of panic grown by line. Who was that? Cybers! Thank you so much for the 5 gifted. Appreciate that. You didn't have to do that, but thank you. Thank you, thank you. Ekipan, how you doing? Ready 1 in 4th for the Commodore 64. In 4th, you're writing Tetris in 4th for the Commodore. Okay, neat. YouTube's recommended me your channel, and I was like, well, that's a coincidence. Welcome. How you doing? How's your week? Yeah, I haven't done any Commodore stuff. I don't know if I'll really ever get around to it. I mean, it is still 6502. But the hardware is obviously different. And I don't have any experience using a Commodore, let alone writing anything for it. Whereas the NES I was already familiar with before this whole journey, you know? Yeah, right. I was recommended on YouTube. I was recommended. Holy shit. If you want to have a look at some of my code, this code isn't up anywhere. But my GitHub is full of NES code and some other random code, some of it to help and whatever. I'm still assembling. How you doing, Standard Pointer? Like I wrote utilities to get, for instance, like this right here. This is from Tiled, right? It's a tiled layout thing. And I can just draw tiles and whatever. Thank you for the sub. Appreciate that. Oh, excuse me. Thank you, Cyber, for gifting another sub. Appreciate it. You already poked through my repost. Thank you. Appreciate that. What are you doing? Thank you, but you're insane. Thank you. Is pausing the game? The pausing is not implemented yet. Not yet. That is going to be something that I am going to be adding. It's not there yet though. I have the code for it is commented out. It's there's some code there for it that is copy pasted from another ROM essentially that I have. I haven't integrated it into this yet. Yeah, the select button holds. Yep. I've got that bound to one of the face buttons on the PS4 controller that I'm using to debug. But yeah, it's a select button. And fun thing. Hang on. Plug it. Stop it. Plug that in. Turn it on. Grab this controller over here. Then in this window, make send. There we go. This is my ROM running on hardware. Oh, I can see the emphasis stuff actually on this. So yes, this does run on real hardware as well. I've got a Famicom off to the side here. I'm using one of the expansion controllers that I didn't actually have implemented at first, and then I tried to use it. And it didn't work. I'm like, oh, I should probably fix that. I should probably like implement the expansion controllers so I can use a controller, like an external controller, right? Because I can also use the built-in like connected controllers for this, right? Which honestly, like, I love the feel of the Famicom controllers. Like the button presses feel really nice. Feels really nice. If you want to pause the emulator, right? Yeah, sure, absolutely. You probably have to be able to read fourth though. I don't know if he's still here, but Bridgewater writes a lot of fourth. I've looked at fourth. I don't write it. So I don't know what I'm looking at. Full disclosure, I have no idea what I'm looking at. Non-portal. Yeah. Okay, so it's fourth for the Commodore. All right. Yeah. So like this, I have no idea what I'm looking at here. Oh, these the Okay. Yeah, those are the pieces there. Okay, so you're defining the pieces of the individual blocks, like their addresses, basically, right? What if everything was a stack? What is this, PostScript? Yeah, so the way I'm storing mine is a lot less efficient on space. Where are they? They're right up here. So I'm storing a 4x4 grid for every single piece. So a lot less efficient than what you have, that's for sure. Where P parses 8 numbers after it. At the fund right above. This is a function definition, I'm assuming. Like I said, I can't really read Forth. I don't know. So I barely know what I'm looking at. Not bad though. Frames per fall. Do you do the different gravity per level, or is it just static? Also, that's kind of fast. Defines name to be ABC. Okay. No gravity curve yet. Okay. Yeah, so 12 for me. 12 is a little fast for me. Like I said, I'm bad at things though. But I've got a it's like a handwritten curve. Where the hell is it? It's around here somewhere. Where did I put that table? Start some lookup stuff. No. I'm not even using these. I don't think these are here. I don't think are used. Are they? Nope. All right, Cybers, you have a good night. Thank you again for the gift subs. I appreciate that. You have a good night. The table knows where it is because it knows where it isn't. Bottom's the time. Where the hell? Oh, I put it at the top, didn't I? Because I needed indexes or I needed it. Yep, right there. Drop speeds. So it starts off at 60 frames per cell drop. And then it reduces that by 5 until it gets to 10. Then it reduces by 2 until it gets to 4. Then it reduces it by 1 until you get 1 frame per drop. Which is very fast. So yeah, 12 is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, yeah, like level 10 and a half, roughly, I guess, for what I have. Commodore 64 runs at 50 hertz, but I don't always manage a full 50. So at the let me change this stuff back. So at the very beginning of the stream, I was doing some profiling stuff, because I want to be able to do 2 full play fields for 2-player in a single frame. Not make, send, no, just make. God damn it, it crashed. Core dumped. Go to hell. This one. All right, flashbang warning. So the NES has what are called emphasis bits. So you turn on an emphasis bit and it emphasizes a color. So these, I emphasize blue, emphasize green, blue, green, and I'm doing that at certain parts of the code, right? So at a certain spot, I am emphasizing blue, so I know I'm in that chunk of code, and then this is like IRQ stuff, and then this green block right here, this is like draw screen stuff, but the green block is all of the frame computation stuff, right? And as you see, let me slow it down a little bit. As I move stuff around and do things, settings, speed, quarter. You see, as I drop stuff and you know, move stuff around and whatever, the time each frame that, you know, stuff is happening changes. So some of this is a little much, even for one player. It's getting on like the upper end of a full frame. I don't know what that red is. I forget what I have set to red. So at the start of stream today, I was getting some of the lower hanging fruit for optimization stuff. So I could update, hopefully the idea in theory, a full dual playfield. This isn't coded yet. This is merely a mock-up. I don't even draw this to the screen yet. Yeah, I'm still working on making stuff a little bit more efficient, to hopefully be able to update 2 full playfields per screen. Now, 9 frames after loading a Tetris. Okay. Okay. Are these drawn like on a background layer, and like the active piece is as a sprite? Is that how that's working? I like how you have the proper colors for all the blocks though. I like that. That's good. Changing the border color as a memory mapped register. Nice. Yeah, so I'm doing something similar for the emphasis stuff. That's all PPU controlled or controlled on the video chip of the NES. So that's just, I write a value to address 2001, which is a register, memory mapped register. These 3 bits right here are turning on and off blue, green, and red emphasis for all the colors. So that's basically more or less the same thing. Similar, very very similar to what you're doing here with the border stuff with timing, to figure out the timing. Now, is what's the white? Is that for like garbage coming up from the bottom? Is that what that is? I might try to do that for 2-player mode, honestly. Oh no, that's clearing, right? Those are lines to be cleared. So I see you dropped a line piece down there. Yeah. Not bad though. Nice. First I mark clear lines and wait 12 frames before deleting them. Okay. Yeah, I've thought about doing some animation stuff for clearing lines, which in theory should help alleviate a little bit of the processing. So I'd in theory be able to spread the processing for clearing rows and moving everything down. I'd be able to spread that across multiple frames if I animate it, depending on how I handle that. I don't know if I'm going to do that, honestly, because that's a bit of work. It might just be easier just to make stuff a little bit faster so I can keep everything in a frame. But yeah, nice. Yeah, because what's it? The Nintendo and Tetris on the NES does an animation like that. Actually, even Tengen Tetris does. No. Each thick blue band is 2,000 cycles, calculated in 4 block coordinates. Cannot afford to calculate hard drops natively. Naively. Ah, okay. All right. So yeah, when you drop that, and you like discover that you need to clear lines, do you just check 4 lines, 4 rows, or do you check the whole board? Yeah, there's a lot. There's a bunch to be optimized. Yeah. That will still be easier than the less time everything it takes. So yeah, still useful. Yeah. Just yeah, okay. Because that was one of the things that that I did from the start was like, all right, well, I'm not gonna check all. I'm not gonna check the whole board if I don't need to. I copy all 21 to the screen. Yeah. So the way I'm doing it is kind of jank and isn't typical of NES stuff, right? So all these tiles are tile 0, like the first tile, right? Actually, let me open it up in Sprite. This right here. So this is my my tile layout, right? This is tile 0, tile FF down there, and I'm not sure how familiar you are with the NES architecture, but for getting stuff on the background, it's a rigid grid of 960 tiles, so they can't overlap on the background at all. I write a tile ID to that grid position, and that assigns that tile to that spot, right? Yeah, so 255 possible tiles available at once, right? And 960 locations. Yeah. So the entire board is actually just this piece right here. This like corner piece. So that's why you're seeing like the grid lines there. Name table that color is 2. Yes. So you'll notice that I'm not obeying the color rules that you typically see on the NES, right? Let's actually open up that window. Debug tile map viewer. Let me change the background color again real quick, so it's a little easier to see what I'm talking about here. No, it's more hackery. Hang on, let me show you real quick. All right, let me change these palettes so I can show you the lines a little bit easier. 0F. Okay, make over here. Reload. That's the wrong window. Reload that. All right, settings, speed, normal speed. All right, I'm gonna put some stuff down on the board here. Not really any rhyme or reason to it. Okay. Now, these red lines are the resolution for colors, typically, on the NES, right? So these are 2x2 blocks. You'll notice that inside these 2x2 blocks are more than one color. This one here has 5 colors in it. 6, if you count the background. So the background's black, right? So that's the edge there. So 1, 2, 3, 4, 5, 6 with that white highlight. I'm doing that with a mapper. Some mapper hackery, right? So extra bit of hardware in the cartridge. It's basically extended attributes mode, where I have, instead of a 2x2 resolution for palette, I have individually addressable tiles for each palette. So each tile can get their own individual palette. So then it just becomes, how many palettes do I have, right? So I am using up all of my palettes. I don't have any spare colors on the background. The only sprites are the active piece and the ghost piece. So if I go down to Sprite Viewer, those are the only 2 sprites. That's the active piece and the ghost piece. Yeah, sprites have the problem that you can only have 8 of them visible in any scan line. Right. So, yeah, it's 10 across, so that that goes out the window. I forget what the limit is for Commodore. So I know you have fewer total sprites, but you can swap sprites mid-screen, right? Like you can change what the defined sprites are mid-screen, right? 100 sprites, but I've never used them. Okay, actually using text mode. Okay, reverse video spaces. All right, not bad. Yeah, so you're using basically just like a all of it's just like a special font essentially that you're doing, right? So you're writing that font to the screen, and that's how you're drawing all the boxes, the box drawing stuff, I assume. But yeah, so yeah, I'm pulling some shenanigans with this. But yeah, it works on real hardware because it's using the MMC5 mapper, which is a Nintendo mapper. What? God! It overwrote my settings, so my start and select buttons are not my start and select buttons. That's what happened when it fucking crashed. Ah! Set up. No. Select is that button. Select, the start is that button. Okay. Select, there we go, okay. Freaking annoying son of a... There we go. Fourth interpreter shenanigans are fun. Here's the 2-minute version. What is this? Oh, nice. Nice. No. What is this? What are you doing? All right, so you interrupted the game and are all right. You're executing like fourth commands directly to progress. Is that what that was? That's funny. Oh, I do like the look of the flat colors though. Someone's outside. There are flashing lights out there. Give me a second. There's a fire truck out there. Give me. I'm gonna make sure it's the building over there. Hang on. There are 4 fire trucks outside. It is the building next door. Oh, there you are. Hey, doing, Bridgewater? I was wondering where you were. Durex for. Wait a minute. Yeah, these one not in LA. Yeah. 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 The images coming out of LA do not look good. My God. Those look dire. Yeah. Yeah. No worries. No worries. I have a little snack here real quick. Give me a second. Oh. Attach 25 trucks to a single fire hydrant network. Guess what? It's oversaturated and can't deliver enough water. You know? That never occurred to me. That never occurred to me. I need to look up how to prime a furnace oil pump. Oh, okay. Good luck. Priming a furnace oil pump. Sure. All right. Where am I? Let's commit some of that stuff there to get rid of the leading zeros. For the level 1, I don't know if I want to use the full that full bin to decimal conversion. So I don't think anybody will be able to get to level 6 million, 16 million, whatever. I don't think. Then again, I guess if you're using a task, all bets are off, but I don't know. I don't know how I want to handle that. Found the instructions for putting the controller into priming mode, at least, but not quite how to open the bleed valve or what to do to actually run the pump. It seems kind of important, yeah. All right. Is it like old hardware or old equipment? Or like relatively new? More Reese's. More Reese's. Give me a second while I have another one. Ow. All right. These are hard to laugh. No worries. The shenanigans, yeah. Suddenly you're playing Tetris like Zork. Like, what the hell? This isn't a text-based adventure. Wait a minute. Hold on. That's not how that's supposed to work. I think that the controller of the burner is new within the past half decade. Okay. But the furnace itself is an old workhorse. All right, there it is. God damn it. Choking on air again. Son of a bitch. I did that at work the other day. Oh my God. Son of a bitch. Ah! Oh God, I hate it. Ugh. Of course, I have trouble drinking water. What the hell? God. That happened at work like yesterday, I think, maybe today. Hell if I remember, but yeah. I don't even think it was down the wrong pipe. It's like swallowed air or something weird. I don't know. All right. No. Yes. No. And no. No. Let me also clear out the lines one, I think, right? Because does it start? Whatever, I'll out of the playfield. Get screens, debug field, and the screens playfield. Add those two. What kind of RNG am I using? Have you heard of XOR Shift 798? You can get great quality random numbers and I think less than 40 cycles. So I was using a linear feedback shift register, shift RNG. The problem I was having was getting the RNG that I wanted. So I'm using the bag system for the pieces. So every 7 pieces, you are 100% guaranteed to get every type of piece, right? So essentially it's grab one of each of the pieces, scramble those 7 pieces. Those are your next 7 those are your next the next 7 pieces that you get. When you run out, do it again. Grab one of each, scramble. Those are your next 7 pieces. Yeah. So because I'm doing that, like you said, the underlying RNG doesn't really matter too much. So what I ended up doing where is it? Which one is it? It's right here. Yes, cost 65. This is my piece RNG. It is 256 bytes long. So in my my frame weight code, util. So there's 2 of them. There's a wait for NMI and wait for IRQ. They basically do the same thing. Wait for the screen refresh to happen, the NMI to happen, and my drawing stuff to happen, right? While it's waiting, increment the index. Just increment it. In a tight loop, just increment. And then when I want to use that RNG, I just load that into like X or whatever, and I use that as the lookup value into this table. And then it's a little bit of code just to make sure that I don't already have that piece picked out. And the most that that RNG will collide is like 7 times, right? Because this table is constructed in a specific way. I am using Go to construct it. RNG tables right here. I'm using this to create that table. Basically, it's 36 copies of 0 through 6. Wait. Oh no. Okay. Okay. So I'm doing a little differently than I thought. So that maximum isn't quite right, but it's rough. It's roughly the same. Whatever. So I've got 30. Whoa. Up, undo. So I've got 36 copies of 0 to 6, and then 36 times 7 is less than 256. So I make up the difference with, I think it's a T block. Is it really T line and square? Yeah, okay, those. All right. So yeah, the T, the I, and the O. There's the square piece. Add those on there just to pad up to 256, and I'm just shuffling it, and this is just printing it out. Cause yeah, I had a lot of trouble with getting an inclusive value between 0 and 7. I'm sorry, 0 and 6. Because for whatever reason, the RNG that I was using just wasn't producing one of the extremes correctly. And I couldn't for the life of me figure that out. So I'm like, you know what? Screw it. Lookup table. Yeah, it was actually like in a soft lock because it couldn't get out of the loop because it couldn't find a unique piece because it for some reason it couldn't generate that last number. But and this works pretty well, you know. And again, like the RNG on this isn't really, yeah, the RNG isn't really that important here because again, like every 7 pieces, I'm guaranteed to get one of each of the pieces, right? Which honestly is the main reason why I wanted to make my own version of Tetris on the NES because the Nintendo version of Tetris and the Tengen version of Tetris, the RNG is just all over the place. It's just, you know, whatever it feels like. What the hell? Why? Huh? It's not registering a button press. What the hell's going on here? What the hell was that? That was weird. It's almost like the Huh. It's almost like it missed the button up. So to get that's a button repeat stuff, right? I'm setting a variable and unsetting it when I release the button. So it's almost like it didn't sense it didn't get the release on that one, which is weird. Really weird. It's the first time that happened, though. That was strange. But yeah, keep it simple. Exactly. Version 652 versions of JSF, XOR shift, XOR Shiro. MPRNGs. I might want to look for XOR shift 798 too. They must have been written the fast dice roller algorithm and the Fisher-Yates shuffle algorithm. All right. It's an 8K ROM kernel. Commodore spelling, not mine. Does your keyboard stuff. Okay. So normally I'd say, oh, the NES doesn't have a keyboard. I have a Famicom keyboard. I think it's behind the curtain, so I'm not going to go and get it, but I do have a keyboard. And I thought about having keyboard input for this as well. Yes, the Family Basic keyboard. Yes. It's around somewhere. I don't know. I'm not going to look for it, though. This guy. Right here. Not that. This right here. So a Bridgewater actually sent one of these to me. So I've got, I have it somewhere. It's around here somewhere. And I wrote a a brainfuck interpreter and compiler in assembly as the project to figure out how to use the keyboard on the NES. I'm sorry, on the Famicom. So I have code to read keyboard stuff. But I don't know if I want to really do that for Tetris. I don't know if I want to try that. The last version of that WebM shows the compiled code size and listed the program names. That right there, 2841? Is that the size of the code? Damn. That's smaller. That is smaller than just my binary to decimal conversion routine. To be fair, though, that's an unrolled routine to do to convert a 24-bit decimal number or binary number into decimal. It does rely on 8K of fourth and 8K of kernel, though. All right. Yeah, I am writing. So yeah, I don't have any kernel to lean on. Yeah. I don't know if that would make it any better if I did, though, because the kernel would be like, 1980s code, and I'm no, ew. I've seen some 1980s code, and dear God, I've done a bunch of reverse engineering for some stuff, and one of them, I don't know where it is. I'm not gonna dig it out. But one of them is the study box. Study box. This thing right here. It's a weird tape drive thing for the Famicom. And the code on this ROM, oh my God, some of it is atrocious, just so bad. It is significantly slower to read the keyboard than the basic controllers. Yeah, so are you having when you're having timing issues, it might not be the best thing to add. Yeah, if anything, it'd be only for the single player stuff, not for multiplayer, right? And again, that's something that like I don't even know if I want to add in the first place. So that's like way down the line, Before that, hell, even before the multiplayer stuff, not that. I'd want to implement some of these other things, right? Like the high scores, at least some game modes. There's a few that I think I can implement rather easily, rather simply. I don't know. The options for a bunch of other stuff. LJ65. That's just LJ. I don't think I've seen that one. Copy. Tetris Wiki. Yeah. Yeah, what happened there? Their database crap out? Cause I found them. I found that wiki the other day, and it was down. Go there. Go there. Come on. Multiplayer is where it could be the most useful, more buttons, but then it also more likely to hit the rollover limit. Yeah, I'd break that horribly. We're giving it to that guy for the NES. Offers a single endless marathon mode with 4 different gravity settings: slow, medium, and fast. Slow, medium, fast, 20G. 2 rotation. Oh, really? 2 rotation systems. Todd rotation and TGM rotation. 2 songs. Okay. Over here. TGM. And is it Todd? It's not on here, is it? What even is? No, all right. Ours, okay. Oh, yeah, that rotation's a little different. Huh. Lockjaw. Tetris the Grandmaster. What was the other one? Todd. What was Todd? Scoring. Drop bonuses. 1 point per row. Line clears. 100 times the number of rows cleared times lines cleared in the current combo. Oh, he's doing the combo calculation a little differently. That's probably the permuting line clears within a combo will result in the same score. Okay. Garbage. Line clear lines of garbage. Adds garbage? Just give me over to YouTube on that one. Don't bother with that. Give me YouTube. Okay. Maybe with the archive.org. I don't know. We'll see. Yeah, it's not gonna. All right. Well. Oh, is this actually 2-player? Oh my goodness, it's got. All right, so it doesn't jump between the cells. All right. Excuse me. Oh, and it does like dithering for the colors. All right. Okay. Nifty. Does this do the bag system, the 7-piece system? For the RNG? Home run? What? What? Famicom title mentioned in whose Discord? Oh, his Discord. I need to get back to titler stuff, honestly. Oh, that's the Long Island Retro Gaming. I've yeah, this thing. This is actually in decent shape, this one here. Like that little pad. Mine was destroyed, that little pad. Yeah. Yeah, the inside of this thing is a sight to behold. It's got 3 separate boards on it. And does he have a picture of... Yeah. This is the Famicom board right here. That is an embedded cartridge. Those are fancy color chips. Yeah. Yeah, the output on this thing is absolutely beautiful. It's beautiful. I've got somewhere. Where did I put that? I'm scrolling up in thing here. Is it this one? I think. Yeah. I'll download it, and then over here I'll open it. Yeah. So this is my key test ROM that I'm opening up here. And this is me demonstrating that I am actually able to read all of the buttons on the face, as well as the little touchpad thing. Horrible resolution on it. But the reason, by the way, I've got this stack right here, this tower. I don't think I have any. I don't think I have it in reach. I got one of them. Is this the one? This is the one I used, actually. Okay. Hang on. So, I've got 2 adapters here that I had to use. This top one, the gray one. So, that cartridge, the EverDrive N8 there, is a Famicom ROM cartridge. That's what I'm using over here. Up there. That's what's running that. That is plugged into a Famicom to NES conversion, right? So it's taking it from whatever the pinout for the Famicom is and dropping it to the NES. And then underneath that, I have another NES to Famicom adapter. And the reason I did that is so I could scratch off one of the lines here. Specifically, whoa, this is like some IRQ line or something? No, what the hell was it? I forget what line this is for. It's pin 15. Yeah, IRQ stuff. Oh right, yeah. So yes, it is. It's the cartridge IRQ. Normally, that's the only place the IRQ comes from. For this touchpad stuff, the system will generate IRQs if it's turned on. So I had to scratch this off because the EverDrive controls the IRQ, even though like I turn off the IRQ. Like I'm using NROM here, right? So basically no mapper kind of chip. At least that's what's supposed to happen. But I guess the implementation in the EverDrive is, oh, we're not expecting IRQ. Pull it fucking low or whatever, right? So it takes control of the IRQ line, which messes up the hardware. So I had to have this stack of adapters, so it didn't interfere with the IRQ. Yeah, it drives it hard instead of doing the proper open collector thing. Right? Yeah. Yeah, I need this thing is still in pieces behind me. The reason it is because I still need to get decent pictures of the boards. Let's see, my most recent attempt at that. Over here, titler. These, nope, not those. It's in here. No, where the hell? Long exposure. There we go. So, still figuring out like the exposure for a lot of this stuff. Where's one that I? This one? Yeah, like this right here. No, that's only 6 seconds. Wait, there's a few that I did like 10-second exposures for. Is it this one? That's 4 second. So I've got like panel lights, right? LED panel lights, and I have a tripod as well that I can like do upside down kind of stuff with. So I set the exposure time stupid high, like 15 seconds, I think. Set the ISO down to 100, and have like a really high f-stop. So the idea is everything's in focus, and I have a lot of time to like get light everywhere. So I just handheld the light panel, right, the LED panel, and just like waved it around a bunch. So I got rid of like shadows and whatnot. Worked out fairly well, actually. This is like one of the other attempts to it. So this one didn't come out as great, but I need to maybe this coming week I'll figure that out, or maybe tomorrow. I don't know. The ROM Barbie cartridge. Yeah, which is actually another ROM cart with the label swapped. Yeah, the front of that one just swapped. Where? I don't even know where that one is, honestly. It's somewhere. Cause I don't use my NES. I use the Famicom for everything. Because the Famicom is the one that has all the fancy fucking peripherals that I can plug into it. Like, oops. Reset that. Reset that, please. Please? Nope. Okay, well, I'll turn it off. Like this here is a controller with a number pad on it because reasons. Where is this one? Yeah. It's got a number pad on it because shut up. It's the Famicom network controller. So it's got 1, 2, 3, 4, 5, 6. It's almost a full calculator, but doesn't have subtract or addition or division. It's got this asterisk and pound, C and dot and 0. I've got a bunch of other really weird peripherals too. Like I have a drawing tablet. I've got a trackball. I've got a dance pad. That's the fun one. The keyboard, obviously. Oh, and those other like really weird. There's the button replay thing that I still need to dig into, and the that other like the turbo button thing as well. I gotta dig into those soon too. But anyway, I do actually need to start wrapping up here. I need to be up early tomorrow because my water's being shut off so it can be worked on at 7:30 tomorrow morning. The bastards, and they're not going to finish until 2 o'clock in the afternoon. So I have to be up early so I can like use the bathroom and like flush before they start. The bastards. So let me wrap up here. I don't have anything else to really. No, hang on. What did I do here? Blog. Commit, amend, score, and lines conversions. Line conversions. Ow, damn it. Hang on. There it goes. All right. Yeah. Yeah, best be done by then. Yeah. Don't forget to grab water to drink either. Yeah. So I need to like prep my coffee tonight so I don't have to worry about like that. Anyway, thank you guys for being here. I'm gonna see if there's anyone to raid real quick. I'm not gonna look too hard, honestly. I'll be back on Sunday doing things. Probably more of this, honestly. It's gonna be more of this. It's gonna be. Let's see. This guy. Yeah, I'll go say this guy. Come with me to say hi if you haven't. Come with me to say hi. I'd appreciate it. Join Discord if you haven't already. Appreciate that. And I will see you guys on Sunday, hopefully. Yeah, so you guys have a good night. Bye-bye. I forgot to type the raid thing. Hang on. Okay, bye.